نحن حكينا قبل بالبندنج ستريسز. شو قلنا على البندنج ستريسز؟ قلنا نحن شو كان عندنا؟ كان عندنا اذا بتتذكروا recall that the types of stresses كان عندنا normal هيك سعيد، عندنا shear. بالnormal stresses قلت لكم how many types في عندنا بالnormal؟ how many types للnormal stresses؟
Two types.
واحدة due to the force، واحدة due to the
moment.
Due to the force is plus or minus force over area, and due to the moment is plus or minus mx y over ix. Now بالشير اللي تعلمناه so far نحن اللي اخذناه قبل، اخذنا عن الافريج شير stresses، عن الافريج شير stress يلي كان اسمه تاو which was equal to the force over the area. ما هيك؟ وقلنا قبل الاريا بتكون parallel ولا perpendicular للفورس in the case of shear؟
Parallel.
parallel to the force. صح. هلا يا شباب بدنا نتعلم فورمولا جديده عن الشير ستريسز which is the correct formula، لانه هاي الفورمولا اللي تعلمتوها قبل انتو it was based on average shear stresses. What we are going to learn today is the correct formula that will give you the shear stress at any point as you go deep and deep in the beam. Okay, يعني what we are going to learn today, so the objective today is to learn the variation of shear stress as we go deep, as we go deeper in the cross section. شو يعني؟ راح اعطيك example. إذا أنت عندك يا جعفر هيدا الريكتانجلر شيب، هيدا الريكتانجلر بيم، تمام؟ This is B, this is H. Or let's say this is B and this is H. هيدا البيم يعني احنا بنعرف انه هيدي الكروس سكشن تبع البيم. هيك يعني انا بس ارسم لك كروس سكشن تبع البيم، يعني البيم فايت لجوا. مفهوم او لا؟ بس يكون عندك ريكتانجلر شيب كانك قصيت البيم وعم بتشوف كيف شكله. This is called the cross section. Understood?
Yes.
Yes.
The shear stress, you will learn today that the shear stress at this point is different than the shear stress at this point, is different than the shear stress at this point, is different than the shear stress at this point. يعني as you go deep into the cross section, the shear stress varies. لأنه according to the formula اللي تعلمناها قبل، هيدي it gave you constant shear stress. ليه عطيتك constant؟ لأنه it was based on average. هلا بدنا نتعلم الفورمولا المضبوطة الحقيقية للشير ستريس يلي رح تقول لك how does the shear stress vary as you go deeper in length. مفهوم لهلا؟
Yes.
تمام. So suppose يا شباب for example, suppose you have this rectangle, this is B equal let's say to 100 millimeter, and this is H equal to 200 millimeter, and you have the cross section is subjected to a shear stress vertically upwards equal to 2 kilonewton. دايما على الكروس سكشن the shear stress بيكون او طالع طلوع او نازل نزول. عم نفهم؟ Okay, so the shear stress on the cross section shear stress the shear force is either vertically upwards يعني لفوق or vertically downwards يعني لتحت. هيدا الشير فورس يلي هو في يلي هو هون، او بيكونوا هن عاطينكم اياه، او you get it from the shear force diagram. Okay, so the force V is either given or you get it from the shear force diagram. So as you notice, it's very important that you know how to draw the shear force diagram and the bending moment diagram. لأنه من البندنج مومنت دايجرام بتطلع الماكسيموم مومنت لتقدر تجيب منها ماكسيموم بندنج ستريس، ومن الشير فورس دايجرام بتطلع الماكسيموم شير يلي منه بتقدر تجيب الماكسيموم شير ستريس. عم نفهم؟
Yes.
Now,
Yes.
what is the formula for the shear stress? It's equal to V times Q over I times T. This is the formula that you will be using from now on whenever you are asked to find shear stresses. This is the formula that you will be using from now on whenever you are asked to find shear stresses. V in here is the shear force, which is either in newtons or in pounds. I in here is the moment of inertia about the horizontal axis, which is either in millimeter to the 4 or inch to the power 4. Tau in here is the shear stress, which is either in megapascal or in PSI. And T in here is the horizontal thickness of the solid cross section. It's the horizontal thickness of the solid cross section, either in millimeter or an inch, at the point of interest. At the point of interest. And Q is equal to A prime times Y prime, where A prime is the area above or below the point of interest, and Y prime is the vertical distance between the centroid of area prime and the neutral axis. هلا بنشوف نعطيكم example، بس خلينا شوي نقرا الجيفن ونجرب نفهمه. So now there is a new formula of the shear stress, which is equal to VQ over IT. V is the shear force. Usually you get the shear force by drawing the shear force diagram كما تعلمنا and finding the maximum value from the shear force diagram. I is easy مثل ما أخذناها قبل. We know how to find I. It's the moment of inertia about the horizontal axis, about the horizontal neutral axis. Q is called the first moment of inertia, and it's equal to A prime times Y prime, where A prime is an area above or below the point of interest where you are trying to calculate the shear, and Y prime is the vertical distance between the centroid of area prime and the horizontal neutral axis. And T is the horizontal thickness of the solid cross section. Let me give you an example. شو رأيكم؟ So given that you have, يا شباب, this cross section where this is 10, this is 50, this is 100, this is 10, and this is 10, and this cross section, يا شباب, is subjected to a vertical shear force equal to 1.5 kilonewton, And the question is 1. Find the shear stress at A. 2. Find the shear stress at B. 3. Find the shear stress at the neutral axis. So you have this point, which is A. You have this point, which is B. And you need to find the shear stress at those points. Plus, you need to find the shear stress at the point on a neutral axis. What is the formula for the shear stress? V Q over I T.
over I.
So the first step is to find the centroid and the moment of inertia. Step 1, find centroid, يعني find إذا بدكم y bar and the moment of inertia ix. How do I find y bar? ناخد reference من وين؟
from
من تحت. بنقسم الكروس section ما هيك into 1 shape, 2 shape, 3 shapes. What is this distance من هون لهون؟
80.
صح. So عندي هون بلش A1 equal, A2 equal, A3 equal, area total equal, Y1 bar, Y2 bar, Y3 bar. What's area 1?
500.
صح. It's 10 times 50, which is 500. Area 2, it's 10 times 80, which is 800.
800.
Area 3, it's 10 times 50, which is 500. And the total is 1,800. What's Y1 bar?
Tw- 25.
صح. It's 50 over 2, which is 25. Y2 bar, it's 10 over 2, which is 5. And this is 50 over 2, which is also 25.
Okay.
So Y bar is 500 times 25 plus 800 times 5 plus 500 times 25 divided by 1,800. Is it clear?
Yes, doctor.
Why, doctor? Why did we divide by 2?
Because so this is 16.11 millimeter. ليه you are dividing by 2 يا مين سأل؟
أنا نايف.
لأنه Y1 bar is the centroid تبع 1 is here. From the reference, it's 50 over 2. Y1 bar يا نايف هي the distance between the centroid and the reference. السنترويد تبع هيدي بالنص. فهمت؟
إيه فهمت الحين.
تمام. هلا بدنا نجيب الاي اكس يلي هي نحن بس نجيب الواي بار نقدر نروح يا شباب لهون and we draw the neutral axis. This is going to be the neutral axis and the distance من هون لهون is going to be y bar which is 16.11. مفهوم؟
Yes.
Now let's find ix. كيف قلنا بنجيب الاي اكس؟ اول شيء بدنا نجيب
اللي قلنا هو
ix2 bar, ix3 bar, بعدين area 1, area 2, area 3, بعدين y1 bar minus y bar squared, y2 bar minus y bar squared, y3 bar minus y bar squared. What is ix1 bar? جعفر تفضل. ix1 bar.
الاكس 1 اللي هي 10 multiply 5 cube
صح.
over
10 multiplied 50 cubed over 12.
50.
I bar x2 is 80 multiplied 10 cubed over 12. And ix3 is 10 multiplied 50 cubed over 12. Area 1 و area 2 area 3 جبناهم قبل. 500 800 500. y1 bar هي هيدي 25. So 25 minus y bar which is 16.11. مفهوم يا شباب؟ هيدي 5 minus 16.11. هيدي 25 minus 16.11 squared. And then ix would be equal to this plus this times this plus this plus this times this plus this plus this times this. عم نفهم أو لا؟
Yes, doctor.
مفهوم. Yes.
So if you do the calculations, تطلع ix is 392,778 millimeter to the power 4. طيب جبنا ال ix. هلا to find tau at this point which is point A. Tau at A is VQ over IT. V is the same. ال V هو يحوي هون 1.5 كيلو نيوتن، بنحولها دائما لنيوتن، يعني بتصير 1500 نيوتن. Q is area prime at point A. It's area prime times Y prime. شو قلت لكم أنا عن الاريا برايم؟ الاريا برايم it's the area above or below the point. You can choose whichever area is easier. فيك تنقي الاريا above the point، فيك تنقي الاريا below the point. إذا بنطلع هون على point A, what is the area above point A؟
10.
لا
multiply
الاريا هي كلها يا عبد الله، يا حياد كل الاريا.
total.
يعني كرمال تطلع الاريا above point A ترسم لي horizontal straight line على البوينت وبتشوف شو هي الاريا اللي فوقه. So if you want to take the area above point A, it's going to be the total area. What's the area below?
0.
0. So which is easier to work with, 0 or the total area?
0.
0. So we can say that area prime at point A is equal to 0, and therefore Q is equal to 0. And therefore the shear stress at point A is equal to 0.
Okay.
لو اخذنا النقطة اللي فوق نفس
لو
الناتج
اخذته
بيطلع
اللي
0.
فوق يا سعيد كانت كمان طلعت 0، بس ما كانت الاريا برايم 0. لو اخذت اللي فوق ما كانت طلعت الاريا برايم 0، بس الواي برايم كانت طلعت 0.
اوكي.
In fact, you can always remember this. دايما على الاكستريميتيز تبع الكروس سكشن، يعني اذا عندك هاي الكروس سكشن دايما على الابر باوندري واللور باوندري، يعني هون وهون شو بيكون الشير ستريس؟
0.
يس،
Zero.
لانه ما في اريا. اذا بتطلع على هيدي البوينت ما في عندها اريا ابوف، اذا بتطلع على هيدي البوينت ما في عندها اريا بيلو. So هون tau is equal to 0 at upper and lower boundary of any cross section. مفهوم لحديت الان؟
مفهوم. انا ساعدني دكتور. ها
مع السلامة. Now, how do I find the shear stress at point B? It's VQ over IT. What is V? Again, it's 1005 Newton. Q at point B is area prime multiplied by Y prime. Who can tell me what's area prime at point B? This is point B. Is it easier to work with the upper area or the lower area?
The lower.
Yes, of course, the lower. So if you draw a horizontal line like this, it's easier to work with this area. So this is going to be your area prime. So the area prime is going to be like this. This is 100. and this is 10. This is point B. Sorry, this is 5. ما هيك؟ يا حي هون it's 5 and this is 100. I'm talking about this area. Understood? So it's 100 times 5, which is 500 millimeters squared. Now, what is y prime b? It's the vertical distance between the centroid of area prime and the neutral axis. يعني this is your area prime ما هيك؟ مش احنا قلنا انه مش احنا اخذنا الاريا prime to be this؟ هيدي مظبوط او لا؟ y prime is going to be the distance between the centroid of area prime اللي هو هون and the neutral axis. So it's going to be y bar minus the centroid of the green area. Where is the centroid of the green area located? From the bottom. Where is the centroid of the green area located from the bottom? From the reference. Where is the centroid of the green area?
5.
لا 5 هي كل هيدي. What is it? شو؟ هيدا الريفرنس. وين السنترويد تبع هيدي الاريا؟
في النص at 50.
2.5.
Which is 5, which is what?
2.5.
Yes, which is 5 over 2. ما هيك؟ So هون y prime is gonna be y bar minus 5 over 2. لأنه أنت إذا بتعمل y bar، أنت إذا بترجع لهون على الفيجر، إذا بتعمل هيدي كلها minus 5 over 2، شو بيطلع لك؟ بيطلع لك الديستنس بين السنترويد of area prime and the neutral axis. عم تفهمها ولا؟
Yes.
شباب
مفهوم.
أكيد مش حاسسكم كتير فاهمين. Are you sure you understood it?
Yes.
So y prime is the distance between the neutral axis and the centroid of area prime. يعني إذا بتشوفها هون يحيي هيدي النيوترال axis. This distance من السنترويد تبع area prime and the neutral axis, this is going to be your y prime. يعني it's going to be y bar, which is this, minus this, which is 2.5. y bar is قد ايه؟ قد ايه y bar؟ 16.11. So 16.11 minus 2.5. So this is going to be your y prime at B. Is this clear?
Yes.
Therefore,
Yes.
now we can calculate Q, which is area prime times y prime. Area prime is 500. Y prime is 13.61. So we're going to have 6805 millimeter cubed. By the way, the units for Q is always millimeter to the power 3 or inch to the power 3. هيدي millimeter to the power 3 or inch to the power 3. هيدي نيوتن. هيدي millimeter to the power 4. هيدي millimeter أو inch. هيدي نيوتن أو pound. هيدي millimeter to the power 4 أو inch to the power 4. عم نفهم؟
Yes, دكتور.
So هلا صار عندي ال V which is 1500. صار عندي ال Q which is 6805. صار عندي ال I which is I computed it earlier 392778. 392778. And now we still have T. T is what? T is the horizontal thickness of the solid cross section. انت اذا بتجي بترسم لاين هون يا جعفر هيك horizontal line What is the horizontal thickness of the solid? يعني من وين لوين عندك solid، من وين لوين عندك cross section. إذا بترسم هون خط هيك. What is the horizontal distance where you have solid? I need answers. I need answers. شو؟ I'm waiting. Please at least try. وين يعني شو هي المسافة يلي تقدر تلاقي فيها solid يعني cross section هيك؟ حدا بيعرف؟ Guys, it's 100. Please.
هي راح
It's 100. من هون ما عندك solid من هون لهون. يا حي من هون لهون. This
Yes.
distance. It's 100. تمام؟ يا حي من هون من هون لهون. This is the horizontal distance. This is t, which is equal to 100. So t in here is equal to 100. And now you can find the shear stress at the point B. Is it clear?
Yes.
تطلع 0.26 megapascal. So the shear stress at point B مش هون not this B, B in the exercise is equal to 0.26 megapascal. Now we still have the neutral axis. If you take this point C at the neutral axis, which area is easier to work with? Area above or area below?
Below.
اب اريا دكتور.
ايه above it's easier لانه below عندك مثل a square like this. Above it's easier. في عندك two
انا
rectangles.
عندي الانترنت ما اسمع عدل.
Okay.
شو جعفر؟ جعفر حكيتني؟ كنت عم اقول لكم انه الاسهل ناخذ الاريا above.
اعتذر الانترنت قطع عندي.
ايه لاحظت. كنت عم اقول لك انه اسهل ناخذ الاريا above لانه الاريا below it's made up it is not made up of simple shapes. يعني اذا اخذت الاريا below بدك تصير مضطر تقسم مثل ما كنا نعمل قبل، بدك تصير تضطر تقسمهم ل 3 areas. So that's why it's easier to work with the upper area. So هون tau c again it's v times q over I times t. It is easier to work with the upper area. It's easier to work with the upper area. يعني هيدا البوينت C الupper area هو هيدا وهيدا. This distance is 10. And who can tell me what's this distance؟ اللي هي من هون لهون. من هون لهون. What's this distance؟
80 25.
غلط. نحن عم نطلع على نيوترال اكسس يا شباب.
هي الواي برايم.
اللي اياها. What's this distance؟
نقص اللي هي نقص الواي برايم من ال 50.
صح. بتنقص الواي
صح
باي
ولا انا غلطان؟
من ال 50. So 50 minus 16.11. So هيدي 50 minus 16.11 which is 33.89. So what's area prime? شباب, I need you to be faster.
33
تفضل.
33.89
Yes.
multiply 10
بس
مضروبة في 2 عشان
صح. So 33.89 times 10 times 2, which is 677.8 millimeter squared. What about y prime, يا سعيد? This is the neutral axis. Y prime, again, it's the vertical distance between the neutral axis and the centroid of area prime. Where is the centroid of area
نقسم
prime?
على نقسم
تفضل.
33 على 2.
صح صح, هيدي هي الواي برايم من هون لهون. So it's 33.89 divided by 2. عم نفهم او لا؟
استاذ اعتذر يوصلني صوتك بطيء، يوصلني متاخر
بس عن جعفر ولا عند كلكم؟
انا عندي مشكله في الانترنت، ضعيف مره عندي.
Deal. So now that we have a prime and y prime, we can find q at point C, which is a prime times y prime. عم نفهم؟
Yes.
So this would be your q. طيب, what is the value of t? What is t at C? Yeah, who can tell me? Where is the horizontal length of the solid? If you pass a horizontal line at C, what is the length of the solid cross section?
نفسها بتكون 100.
غلط. هون يا سعيد, do you have any solid على point C? طلع.
0.
على point C هون, do you have any solid?
Oh, no.
Okay, so what's the solid?
10
هيدي?
plus 10 plus 10.
Yes, it's 10 plus 10.
Okay.
So it's 10 plus 10, which is 20 millimeter. مطرح ما يكون في solid بس. This is T.
Okay. مفهوم.
So now we can find the shear stress at C, which is VQ over IT. V is 1,500. Q is 11485. I is the same as before. It's 392,778, and T is equal to 20.
يعني ال V وال I ما بتتغير.
لا. بيطلع 2.193 ميجا باسكال. Am I clear?
Yes.
Yes دكتور. Yes.
Let's solve this example. A steel wide flange has the dimensions shown in figure 711A. If it is subjected to a shear force of 80 kilonewton, plot the shear stress distribution acting over the beam's cross section. So this is an I beam. ما هيك, this is an I beam لأنه شكله مثل ال I. So the first step, step 1, is to draw a cross section of the beam. كيف بدها تكون هاي الكروس سكشن؟ هيك. This is an I beam. هيك او لا؟
Yes.
This distance is 300. This distance is 20. This distance is 15. This distance is 20. And this total distance is 200 من هون. لا sorry. This distance من هون لهون is 200. يا حية من هون لهون. It's 100 plus 100. مفهوم الحين؟
مفهوم.
Step number 2, find
Find y prime
y bar and ix. صح. Where is y bar يا سعيد؟ دغري. Where is y
في
bar؟
النص.
صح. ليه؟ لأنه the system is symmetric. From the reference, y bar is 20 plus 200 plus 20 over 2, which is 120 millimeter. Whenever the system is symmetric with respect to a horizontal axis, then this is going to be your neutral axis. This is y bar equal to 120 millimeter. How do you find ix?
300.
To find ix, we
نحتاج
need
الاريا.
to divide the cross section مثل ما عملنا قبل. تمام؟ You cannot find ix without dividing the cross section. شو؟ مفهوم؟
مفهوم يس.
So let's divide the cross section. 1, 2, and 3. What is ix1 bar? It's 300.
300 multiply 20 over
صح. ix2 bar. It's 15 multiply 200 cubed over 12. ix3 bar. كمان.
equal ix1.
صح. What is area 1? It's 300 times 20, which is 6,000. What's area 2? It's 15 times 200. Area 3, it's 300 times 20. What is y1 bar minus y bar squared? What is y1 bar?
ten.
صح. 10 minus 120 squared. What is y2 bar minus y bar squared? What is y2 bar?
10 plus 100.
غلط.
20
صح.
plus 100.
صح. It's 120. So it's 120 minus 120 squared. And y3 bar minus y bar. What's y3 bar?
نفس الشيء 10.
10 minus
مش 10. كيف 10؟
20 plus 200 plus 10.
صح. 20 plus 200 plus 10 لأنه هي من هون لتحت. So 220 230 ما هيك؟ minus 120 squared. إذا بتعمل again to find ix شو بنعمل؟ يا شباب نحن شو بنعمل to find ix؟ This plus this times this plus this plus this times this plus this times this. مش هيك؟ أو لا؟ 300 times 20 cubed over 12 times 2. شو يا شباب؟ عم نفهم أو لا؟
واضح كثير دكتور.
أكيد؟
أكيد.
يطلع لك الاي اكس 155600000 155,600,000 millimeter to the power 4. Now عم يسألك to find the shear stress distribution whenever they ask us to find the shear stress distribution ناخد نقطة فوق point A نقطة على ال point of discontinuity ونقطة على ال neutral axis. تمام؟ so ناخد نقطة فوق نقطة على ال point of discontinuity ونقطة على ال neutral axis. نفهم؟
Yes,
So
دكتور.
you need to find the shear stress at A, the shear stress at B, the shear stress at C. What is the shear stress at A?
0.
Yes, thank you.
What kind?
So now tau A, tau B, tau C. نحن اتفقنا قبل انه tau A is 0 لانه it is on the upper extremity. What is tau B? It's VQ over IT. What is V? V is given 80 kilonewton. بنحولها لنيوتن, so 80,000 Newton. What is Q? It's area prime times Y prime. Now, Saeed, what is area prime at B? Is it easier to work with the upper or the low area?
لا upper.
Upper. So what is it? Can you tell me what is it?
20 multiply 300.
صح. So if I want to work with the area prime at B, it's the area above B. It's easier to work with the area above B. Yani we're gonna choose this area. This is point B. This is the neutral axis. I'm going to work with this area prime, which is 20 times 100. So area prime at B is 20 times 100, which is 2000 millimeters squared. محمد او مين معنا؟ بس جعفر. What is Y prime B?
Y prime اللي هي 10
ايه 10 plus شو؟ plus head distance.
بلس
خلينا نشوف شو head distance.
100.
صح, هاي من هون لهون هي 100.
لا. اوكي.
So it's 100 plus 10 يعني 110. مفهوم؟
Yes, دكتور.
And therefore Q is equal to 2000 multiplied by 110, which is 220,000 millimeter cubed. Saeed, what is the thickness at B?
Uh, 15.
يا عيني عليك. هون لانه بي جاي على الديسكونتينيوتي فيك تاخذ الثيكنس تو بي 300 فيك تاخذ الثيكنس تو بي 15. رح ناخذهم اثنيناتهم نحن. هون T can be 15 او it can be 100. Do you agree with this?
Yes.
لانه فيك تاخذ كل هيدا اللاين وفيك تاخذ هيدا اللاين الصغير بس. لانه point B جاي على الديسكونتينيوتي يعني whenever the point is on a discontinuity and you want to plot the shear stress distribution, take both thickness, take both cases. However يا جعفر إذا السؤال كان find the shear stress at B هيك بس find the shear stress at B, then you take the smaller distance.
سعد راتب 300 مو 100.
صح 300 مش 100. كنت عم اقوله يا سعيد انه لو السؤال كان
لو هو محدد لي
لو قايل لك find the shear stress at B تاخذ الاصغر distance, بينما اذا السؤال كان plot the shear stress distribution تاخذ both distances. So if you are only interested in finding tau B, take smaller distance اللي هي شو 15 ملم. تمام؟ So هون صار عندك two shear stresses tau b plus and tau b minus. Am I clear? Am I clear?
Yes.
So what is the shear force? It's 80,000. What is Q for point B? It is 220,000. What is I for the cross section? It is 155,600,000. هون التي رح ناخذها 300. هون same numbers, however T is going to be 15. Am I clear?
Yes.
جعفر؟
يس دكتور.
So هاي بتطلع 0.377 ميجا باسكال، وهيدي اللي تحت شو بتطلع؟ بتطلع 7.54 ميجا باسكال. We still have one more point to go, which is what? The point at the neutral axis. So now tau at C is VQ over IT. ال V ما راح تتغير. It's 80,000. ال Q هي area prime times Y prime. What is area prime at point C? Does it matter if you take the area above or the area below in this case?
ما بتتغير لو خذيناها فوق ولا تحت.
صح، هي ذاتها. هي ذاتها. بس I'm gonna choose to work with the area above. So to find the area above, area is area above C. هيدا C هو هون. This is the neutral axis. صار عندك هون multiple shapes يا جعفر. Whenever you have multiple shapes, this is going to be your area prime, ما هيك؟ This is
Yes.
20, this is 300, and this is 100. شو بعمل لما يكون عندي multiple shapes? I need to divide them into shape 1 and into shape 2. So area 1 is equal to 100. This is 15. Multiplied 15, which is 1500. Area 2 is 300 multiplied by 20, which is 6,000. Then the area total, which is equal to area prime, is equal to what?
7,500.
No, 9 million. Sorry. Yes, my bad side. Yes, 7,500. So this is your area prime. So area prime is 7,500 millimeters squared. Who can tell me what is Y prime? What is the definition of Y prime?
النقطة اللي بتكون من
بلس 100.
رجع عدلي. جعفر رجع عدلي.
10 بلس 100.
انتبه. الواي برايم يا جعفر هي the distance, the vertical distance between the neutral axis and the centroid of the cross section.
I'm sorry.
How do you find the centroid of the cross section?
لازم نطلع الواي برايم.
Yes, you have to do like we did earlier. You have to pick your reference من هون. And you have to choose, you have to put y1 bar equal 100 over 2, which is 50. y2 bar equal 100 plus 20 over 2, which is 110, and then y prime would be what? 1500 times 50 plus 6000 times 110 divided by 7500. Am I clear?
Yes.
Should be 98 millimeter. هيدي غير اللي جبناها قبل. عم نفهم او لا؟
ايوه
هيدي it's a new y prime that is only concerned with this area. So therefore, Q is A prime Y prime, which is a del A prime
7500
times 9,
multiply.
which is 735,000 millimeter to the power 3. What is the thickness at point C? هيدي point C هون on neutral axis. What is the thickness at point C?
15.
Yes.
15 the same
So,
دكتور.
the shear stress at the neutral axis is VQ over IT. V is 80,000. Q is 735,000. I is 155,600,000. And T is 15. So the shear stress at the neutral axis is what? Is 25.192 megapascal. Now we can draw the shear stress distribution. عندنا tau A0, tau B plus with tau B minus with tau C. What is tau C plus tau B plus? It's 0.377. Tau B minus, it's 7.54, and this is 25.192. So you have this cross section. هيك يا جعفر. You have this
Yes,
is the
doctor.
neutral axis. This is the shear stress. What is tau at point A? It's 0. So راح نبلش من 0. What is tau at point B plus? مرة بتكون 0.377 بعدين بتنط ل 7.54. هيدي B. و C it's 25.192. To join these, you always join them in a parabolic way. يعني like this, بعدين it's gonna be straight, بعدين it's gonna be like this. And since the system is symmetric, then you're gonna have the same shape. You're gonna have the same shape from the other side. دايما the shear stress varies parabolically. يعني whenever you want to join the shear stress distribution, you do it in a parabolic way. عم نفهم؟
Yes.
So بلشنا من الزيرو بارابوليك على اللي هون، بعدين صار في جump. لانه ليه كيف صارت الجump؟ لانه الثيكنس تغير. بعدين جينا لهون على الماكسيموم، بعدين كفينا ورجعنا على الزيرو. Am I clear?
Yes دكتور.
Yes.
يا حيون. If I think we have a problem with the calculations, uh, guys, I think we have a problem with the calculations. Let me check, please. Okay, الكيو هون غلط. It's 20 times 3 times 110. هون it's times 300. هي اخذتها 100. مظبوط. هون عملت غلطة اخذتها 100. So let me correct this. So this should be 20 times 300. يعني راح تصير هون 6000. هيدي راح تصير 6000 times 110. So 6000 times 110 تطلع 660,000. And then this would change in here 660,000, and this would also change in here. عم نفهم؟
Yes, دكتور.
This would change. So 80 times 660 times 10 to the power 6 divided by 1,55600 000 times 300. This is going to be 1.13. And the second one would be 22.62. Mimi. Now it worked. And the final one is 25.2. So this is 22.62, and this is 1.13. Am I clear?
Yes, دكتور. Yes.
Yes.
Okay. I want to solve question number 4 from the homework. هيك بنشيله من دربنا. تمام؟ شو رأيكم؟
Okay, دكتور.
And then we
Okay.
will be done for today. Draw the shear and bending moment diagram for the beam shown below and determine the shear as a function of x and the moment as a function of x. If the beam cross section is 1 shown beside the beam, calculate the following. طيب. Let's first draw the shear and bending moment diagram. What is the first step before we draw the shear and bending moment diagram? Step 1, we need to find the reactions. How many reactions do I have in here in this system? This is A, this is B, this is C. How many reactions do I have?
عندنا at A3 reaction.
صح، عندنا AY وعندنا AX
Moment.
وعندنا moment at A. So let's find the reactions by applying the equations of equilibrium. Summation of forces in the y direction بيطلع عنا plus AY minus 45 minus 35 times 1.8 is 0. Do you agree with this?
Yes. دكتور.
Yes.
بيطلع ال AY is 108 كيلو نيوتن. If we do summation fx بيطلع معنا انه ال AX is equal to 0. If we do summation of moments at A بيطلع معنا plus MA. شو كمان عندي؟ يلا plus MA
يكون عندنا هذا distribute نطلعها دكتور.
so minus 35 times 1.8 times شو 35 times 1.8 تعطيك الريزلتنت times شو
نقسمها على 2 ال 1.8
divided
over
by
2.
2. What about this?
45
Plus or minus?
minus with clockwise.
Minus 45 times
3.
3. وهيدي
Yes.
plus or minus?
ماينس.
صح.
هذه ماينس عكس عقارب الساعة نفس the same. انتي clockwise.
So بيطلع المومنت is 271.7 كيلو نيوتن متر. طلع positive يعني in the same direction as assumed. In the anti-clockwise direction. عم نفهم؟
يس.
Yes, clear.
Okay. Now that I have the reactions, how do I draw the shear and bending diagram? نحن تعلمنا step 2 draw أو قبل step 2 find the shear and moment as a function of x. هو هون طالب before drawing the shear and bending diagram ليك شو قالنا؟ determine the shear and moment as a function of x. هيدي it's the other way of drawing the shear and bending moment diagram. It's the hard way. It's called the method of equations. يعني كرمال نحن نقدر نرسم الشير and bending diagram we have to take cuts and find equations of v and m as a function of x. How many cuts do you think we should take in this system? We always take a new cut whenever there is a new load or whenever the load changes. How many cuts do you think we should take?
3 cut.
3 cut.
2 cuts. وحدة هون وحدة هون. 2 cuts.
مطرح القوة الفورس.
نعم؟
مطرح الفورس.
يعني من A ل B من A ل B عندك 1 cut لأنه اللود ما عم يتغير. At point B صار في عندك moment and at the same time load تغير بطل rectangular. So we take another cut من B لعند C. Now in cut number 1 is it easier to look from the left side or the right side? In cut number 1 is it easier to look from the left side or the right side?
من اليسار أسهل.
يسار أسهل. So we take cut number 1. In cut number 1, what is the range of variation of x? هي x. من وين لوين؟ من وين تبلش وين بتخلص؟ شو guys؟ In cut 1, what is the range of variation of x?
1.8
صح؟
minus
لا, it's between 0 and 1.8. At this point, x is 0. At this point, x is 1.8. So it varies between 0 and 1.8 meters. تمام.
تمام.
And if you take a cut like this, this would be x, and this would be 35 kilonewton per meter. And if you take the cut, you would have a normal force like this, a shear force like this, and the bending moment like this. هون رح يكون عندك ال AY يلي هي 108 كيلو نيوتن، وعندك ال MA يلي هي 271.7 كيلو نيوتن متر. Do you agree with this?
Yes.
جعفر?
Yes, دكتور.
Okay. So to find the shear and bending moment as a function of x, I'm gonna apply the equations of equilibrium. أول شيء summation of Fy equals to 0. يعني minus V minus 35 times x plus 108 is 0. So V is 108 minus 35x. Agreed?
Yes.
Yes, دكتور.
Now, at x equals to 0, يعني the shear at A, what is it going to be? إذا بتحط هون x equals to 0, بيطلع لك shear is 108.
108.
At x equals to 1.8, the shear at point B would be 108 minus 35 times 1.8, which is 45. مفهوم لحد هلا؟
صفات.
مفهوم.
Yes, دكتور.
بنكفي على summation of moment about the section is equal to 0. شو عنا moments؟ عنا m plus m، عنا هيدا plus or minus this loading, plus or minus.
Minus.
Wrong.
Minus.
Wrong. About the section.
Minus لأن أنت
Anti-clockwise. It's plus.
Okay.
نحن بنعمل summation
Yes,
of
yes.
moments about the section.
Okay.
So like this.
Okay.
So it's plus شو? Plus 35 times x times what? 35 times x تعطيك ال resultant. Times what? 35
ما
times x تعطيك هيدا.
Times
Times
X.
x over 2.
صح. What about this? Plus or minus 108.
Minus.
صح. Minus 108 times what? Times x.
Yes.
وهيدي plus or minus
Plus.
plus 271.7. So بيطلع عندك انه the moment is equal to minus 17.5 x squared plus 108x minus 271.7. This is the equation for the moment of cut 1. Again, at x equals to 0, at x equals to 1.8. At x equals to 0, you can get the moment at A, which is going to be minus 271.7. And at x equals to 1.8, you can get the moment at B. مظبوطة ولا لا؟ Minus 134.
مظبوط.
Is it clear for now?
Yes.
Yes, دكتور.
Now I still have one more cut to do. Right? Which is what?
اللي هو البي سي.
Which is cut number 2.
بي سي.
Yes, BC. So cut number 2. لأنه قايلنا to find it as a function of x, we are obliged، نحن مجبورين نشتغل من ميل اليسار لأنه الإكس مبلشة من هون. تمام. So we have to look at the left side.
Yes.
What is the range of variation of x between B and C? من هون لهون. At this point, what's x?
1.8
At this point,
1.2
لا
Oh, 2.
لا لا x مبلش من هون.
نفسها.
لا
1.8 بلس 1.2 يعني 3.
yes it's 3. هاي كلها من هون لهون هي x. نفهم جعفر؟
نعم.
So هون x
اي
varies.
يس دكتور 3.
clear. So x بين 1.8 وبين 3. This is gonna be 35 kilonewton per meter. هون عندك 108 كيلونيوتن. هون عندك 271
يعني
point.
صارت هذا المسافه 3 ماينس اكس.
نعم هيدي
بعدين راح تكون 3 ماينس اكس يعني نضرب، لا راح بعدين راح نضرب 3 ماينس اكس يعني نضربهم في
هلا بنشوف. هيدي 80 كيلو نيوتن متر. هيدي كلها يا جعفر من هون لهون هي اكس، وهيدي 1.8. What is this من هون لهون؟ إذا هيدي كلها اكس هيدي 1.8 تكون اكس ماينس 1.8
1.8
ما هيك؟ and هون أكيد عندك الشير والمومنت دايجرام والنورمال فورس. Again, what do I do to find the shear force
أولاد the equation
of forces? Minus V minus 35 times 1.8 plus 108 is 0. So V is 45 kilonewton. Summation of moments about the section is equal to 0. This is the section. يعني plus M. شو عندي كمان؟ يلا بسرعة.
بلس 35 multiply x minus 1.8.
غلط. أول شيء multiplied by 1.8 هيعطيك الفورس. مش هيك يا
اوكي
جعفر؟
ام سوري.
بعدين
بعدين
multiply.
تضرب في هذه.
بعدين بدك تضربها بهاي كل الديستنس، بهاي كلها يلي هي x minus 1.8 plus هيدي يلي هي 1.8 over 2. Did you get me?
yes
جعفر؟
يس دكتور.
اوكي.
يس دكتور. ده الانترنت الباقي.
دي عندنا هون minus 108 times x يلي هي جاي من هون، وعندنا المومنت يلي هي تبع هيدي which is plus 271.7، وعندنا المومنت يلي جاي من هون which is minus 80 is equal to 0. So M plus 63 times x minus 0.9 minus 108x plus 191.7. M plus 63x minus 56.7 minus 108x plus 191.7 is equal to 0. يعني M is 45x minus 135. Are we clear? If you put
Yes.
x
Yes,
equals to
doctor.
1.8 و x equal ل 3 x equal ل 1.8 بيطلع لك the moment at B. Okay? Sorry guys, 1 second please.
No problem, doctor. Take your time.
هون when you replace x by 1.8 شو بيطلع لك؟ بيطلع لك المومنت at point B. ما هيك؟ if you calculate it تطلع minus 54 كيلو نيوتن متر. And if you do x equal ل 3
0.
بيطلع لك 0. Now we can draw the shear and bending diagram. لو ما قلنا to express them as a function of x كنا استعملنا الميثود يلي نحن بنشتغل فيها عادة. لما يكون vertical force يعني بيصير في jump على shear force. عفوا؟
اللي هي diagram.
طيب هلا عندنا هذا الفيجر. This is point A, this is point B, this is point C. You have in here 108 كيلو نيوتن متر، سوري كيلو نيوتن، وعندك هون 271.7 كيلو نيوتن متر. Now we are going to draw the shear and the bending diagram. This is the shear. This is point B. This is A and this is C. بcut number 1 يلي هي هيدي الكات يحيي هيدي الايكويشن تبع الشير. At point A it's positive 108 يعني نجي لهون and we draw plus 108. At point B it's 45 يعني نجي لهون and we draw 45. How do we join these points? Like this, or straight?
Straight.
ليه؟ ليش يا سعيد؟
والله اني ناسي لكن
لما يكون اللود هوريزونتال الشير بيكون ستريت.
اي صح، والمومنت بيكون
بارابوليك. مزبوط.
بارابوليك.
Now ما خلصت. In cut number 2 يلي هي هيدي the shear is constant to be 45. It's not a function of x يعني بتكفيه جالس بعدين بتسكره. مفهوم؟
مفهوم.
بنكفي على المومنت
Yes.
كيلو نيوتن متر. Again we have B, have C, we have A. نطلع على cut number 1 بنلاقي انه the moment at A is minus 271.7 يعني هون minus 271.7. The moment at B is minus 134 يعني هون minus 134. How do we join these? Like this, or like this? What do we have to use?
هذه بتكون بوزيتيف ديكريز.
يعني عليك. ثانك يو سعيد. positive decreasing شو يعني؟ هيدي.
ايوه هذا الربع.
لا هذا الربع. سوري هذا الربع. معك؟ هون negative decreasing. هون negative increasing. مزبوط يا سعيد او لا؟
مزبوط.
So it should be like this. So like this. بعدين من B ل C at B is minus 54 يعني you have to have a jump up until
مش
minus
واقفه عند
54.
الشاشه ما ادري ليش.
شو حبيبي؟ شو جعفر تفضل. بعدين من بي لسي شو عندي؟ كيف بدك تحركهم من بي لسي؟ ركز لي هون، كيف بدي اطلع من بي لسي؟ المومنت ات سي از زيرو، شو بدي اعمل؟ المومنت هون از minus 54، المومنت ات سي از زيرو، شو بدي اعمل؟ How will I go from B to C؟
ستريت لاين
ليه؟
لانه ما في تغيير.
صح، لانه shear is constant. When the shear is constant, the moment is straight. What is the maximum shear? What is the maximum moment?
اللي هي تكون بالسالب.
صح،
20
سالب minus 271.7 كيلو نيوتن متر. Did you understand?
Yes, doctor.
I want you to solve the rest of the problem. We will continue with it tomorrow.
Okay.
ان شاء الله.
We will continue with it tomorrow and we will continue with the rest of the homework. Okay?
Okay.
Try to solve all the homework by yourself if you can. I will see you tomorrow. Bye, guys.
Thank you.
Thank you.